All right, welcome back, everyone. I wanted to give a little bit more insight into the extra credit questions if you were interested in trying 14 and 15. The math itself isn't too difficult. If you look at questions 14 and 15, they're going to ask you to find the inverse and then state the domain and range. So finding the inverse shouldn't be anything too tricky, but these are going to be special cases where we got to be really careful with our domain and range. And I'm going to kind of try and explain that. It helps to kind of think about it visually. So our original function is just f of x equals the square root of x. So let's just find our inverse really quick. So I mean, you would just rewrite it, swap your x and y, solve for your y, so you'd square both sides. You would basically get x squared equals y. So that's your inverse. You get that your inverse of the square root of x would just be x squared. But let's look at this visually. So I'm going to graph our original function in green. So I'm going to kind of just put that on the side here. That would look something like this. And you can plot that in Desmos if that helps you get a better picture. But we're just trying to think about it roughly right now. I'm going to graph my inverse in red. So if I graphed x squared, that's just your kind of your standard parabola, right? The one thing that should never happen when you find an inverse, it should never change the shape of your graph. Like, I mean, if you look at what I plotted in green and what I plotted in red, those are not the same graphs. I mean, the green function is basically half of that red function, right? So that should never happen when you're taking your inverse. Your graph itself should not change. Remember, it just swaps your x and y. So sometimes we have to restrict our domain and range, because when I flip this over, you're going to see, like, if you can kind of visualize it, it would be basically this part of our graph, not this part. Like, this is extra. We kind of created some extra stuff when we found our inverse. And it kind of relates to sometimes when you get kind of extraneous solutions in a way. So what we need to think about is, first off, what would the domain and range of my original function be? You could look at it visually on your graph, or you could just think about it algebraically. Like, what can't you plug into a square root function? Remember, you can't have negatives underneath the square root. If you have a negative, you get imaginary solutions, and we're just looking at our graphs. We're not talking about imaginary solutions. So our domain would basically be every x greater than or equal to 0. You can take the square root of 0, but you can't take the square root of -1. And you could also look at your graph. Like, if you just look at that green function, that would be your domain. It's everything bigger than 0, right? Our range, basically, is there anything a square root function can't equal? Well, if you think about it, if you're square rooting positive numbers or square rooting zeros, you can only get a positive answer when you square root something. Like, if you square root 5, you're going to get 2 point something. If you square root 25, you're going to get 5. If you square root 0, you're going to get 0. There's nothing you can take a square root of and get a negative number. So our range would also be greater than or equal to 0. I mean, you could also look at your graph, but you should see that visually. But you kind of want to think about it algebraically. One kind of thing that I didn't emphasize probably enough, when you find the domain and range of your original function, it swaps for your inverse function. It's basically the idea that you swap your points, your x and y swap. So really your domain and your range swap. So for my inverse function, my domain would be really, since it was this, since its domain is going to be x, but it'd be x greater than 0, and our range would be what I had here, which same thing with the y. And I know these are the same, so basically you swap these around for your new function. So if they're not the same, like they swap. So say this was like a 2, like say your domain for the original was x greater than or equal to 2, your range is going to be y greater than or equal to 2 for your inverse function, if that makes sense. So like, maybe just to visualize, say this was a 2, that would change this to a 2. But obviously that's not what we have in this problem, but just since they're the same, I want to make sure that's clear. But you also want to you just want to kind of double check with yourself. Is there anything that would be restricted on my new function? Well, I mean, first off, you can plug everything into an x squared. Like, you can square any number, no big deal. You can square negatives, you can square fractions, you can square 0, like -2 squared is 4, no big deal. So there's no restrictions, extra restrictions on the domain. And x squared can equal only positives, but we already have that restricted. Like, I mean, like, for example, -2 squared is +4. So like, for example, if our range wasn't restricted, we would restrict it more. But basically what that means in our graph. So this is our, sorry, I didn't mean to erase that. But basically what that means in terms of our graph is that our domain and range are restricted. So we're only looking at x is greater than 0 and y is greater than 0. So that, I was actually wrong earlier. That would just be this part of my function. So basically this is not part of my inverse. Like if you flip it over, it would just be that half of the parabola. That's what this restriction is telling you. From the x squared graph, we're only looking at this part of our domain and range. And you should see now, looking at this graph, these are the same shapes. They just reflected over that line y equals x. So I hope this makes a little bit of sense, but basically the big idea is sometimes when you find your inverse, you can kind of create extra parts to your graph, or you can change the initial shape of your graph. So it's really important that you look at these domain and range restrictions on your new function, because that will make sure, because the whole x squared, like the whole function, is not going to be part of your solution. And this directly relates to why we get extraneous solutions. Like if you had one of your solutions was on part of that graph I just crossed out, that would be extraneous. It's not truly part of your inverse. So maybe this gives a little bit more insight into why our extraneous solutions a lot of times are extraneous. But we're going to look at one more problem. All right, so for the second problem I was going to look at, our original function is f of x equals 1 over x plus 2. I kind of drew a sketch of this. You might want to plot this in the Desmos if you want to see a picture, but this is probably a graph you've never seen before or have a name for. This is actually called a hyperbola. It's kind of like, how to describe it? I don't know if you, well, next chapter we're going to look at exponential functions. So I don't know if you're familiar with what an exponential function looks like from algebra 1, but basically it's kind of like two exponential functions in a way. That's kind of the shape it makes. But this is called a hyperbola. We'll probably look at this later, depending on how far we get this year. But basically, I mean, if you find your inverse pretty quickly, let's just kind of do that. Remember, rewrite it, swap your x and y, solve for y. So you'd actually want to multiply this denominator over. You'd have x, y plus 2 equals 1. Divide the x back over. So you'd have y plus 2 equals 1 over x. You could subtract the 2 over. So sorry, I know I'm going a little bit quick, but I'm not really worried about necessarily the solving problem. But you would get that your inverse is 1 over x minus 2. Okay, so if one thing, like I said, we want to think about in our original function, are there any domain restrictions? You could kind of look at your graph, or you could, I would encourage you to think about it algebraically. Is there anything like when you have a fraction that you can't have when you plug something into it? Like with fractions, remember, you can't ever have 0 on a denominator. That's the one problem with fractions. You can't have 0 on the bottom. If you divide by 0, the universe explodes. Math breaks. So you can't have 0 on the bottom of a fraction. So you want to ask yourself, basically, for your domain, what would make the bottom of this fraction equal 0? Well, -2 would. So basically, we could plug everything into this function except -2. So it'd be all real numbers except x can't equal 2. Or sorry, -2. So if you plug in -2, that's the only problem. But everything else you could plug in, no worries. Our range is a little bit, got to think about a little bit. Is there anything this fraction can't equal? Well, if you have 1 over something, for example, 1 over 5 is going to be a fraction. You could get 1 over negative something. There isn't really a restriction on our range, except 1 over something is never going to equal 0. You could have 1 over a positive number. You could have 1 over a negative number. You could have 1 over a decimal, which, like, for example, like 1 over 0.5 would be 2. So if you get decimals, you could get bigger or smaller. But you can't have 1 over something and have your function equal 0. And if you look at your graph, like, you might notice like if you look at it visually, if it helps, you might want to put this in Desmos, but you're going to notice that your domain doesn't equal zero, but basically it's everything. Sorry, your range doesn't equal zero, and your domain is never going to equal -2. Like it's going to get like closer and closer to that, but never cross. So our range is all real numbers except x, or sorry, y can't equal zero. Because if you have 1 over something, you can't have 0. Like 1 over what would equal 0? Like 1 over 1 is 1. 1 over, like 1 over, you can't come up with something that would equal 0. The only way to have 0 for a fraction is 0 over something. So if you have 1 over something, it's never going to be 0 over something. So this is our restriction. So like I said, when you find your domain and range for your inverse, oops, I'll put it way down here, I guess, with our inverse. Remember, you're basically your domain and your range from the original swap. So my domain would be all real numbers except x can't equal 0. And then my range would be all real numbers except x can't equal, y can't equal -2. Just make sure you swap the x and y for like domain and range. But then we want to ask ourselves, are there any other restrictions from this new function we came up with? So we have 1 over x minus 2. So remember, with fractions, you can never have 0 on the bottom of a fraction. So we can't plug 0 into this new function because 1 over 0, that would be a problem. So we already have that in our restrictions. We have x can't equal 0. But if that was something we didn't have already, we would need to add it to our new function. So you just kind of want to double check. And then for our range, if you think about it, remember, 1 over something can never equal 0. So I can't get 0 minus 2. So I can't get -2 for this function, which we already have in our range restriction. But if we didn't have that, we would need to add it to our restriction. So sometimes when you're finding your domain and range, you might have another thing to add, maybe like x can't equal 5 or something, maybe something switched. But this problem, it still checks out. Like from what we have, this works for what we have here. So this would be our new domain and range. Basically, you swap what you had, but you got to consider the restrictions from the original. That's kind of the idea. Because if you don't have something in your original function, when you swap your x and y, you're still going to have kind of the same kind of issue, but swapped in terms of your domain and range. So I hope this was a little bit helpful. I'm sure it's still a little bit rusty, but basically visually, just keep in mind, sometimes when you start with your original function and find the inverse, you might create extra stuff. So you just want to make sure when you get your answer, sometimes you have to think about if you have to restrict your domain or range. So please ask questions, but I hope this maybe gives a little bit of insight in case you're going further along with this next year.